seen the DNS. The last very short introductive part of this application layer protocols is for peer-to-peer applications. So far, we have only looked at applications based on the client-server model. So peer-to-peer applications are also used, very spread around, and they are used for many purposes. Now we will only have a look of the peer-to-peer applications that are suitable for file sharing, which is one of the easiest tasks you can imagine. So in peer-to-peer file sharing, the user runs peer-to-peer software on the PC. It connects to internet in a discontinuous way, so each time it gets a different IP address, and it looks for a file for, let's say, video content or other types of contents, which is made available by somebody in the network. Initially there is not specific knowledge of the location where this file is available. And the peer-to-peer application works when there is a pool of users that are wishing available to share files in the pool, so that each one can download files from the others, but at the same time he have to make files of his own local collection available for others to download. So the problem is, before downloading the file, how can we locate where this file is contained? So who is the host that is able to provide the file? So there is a phase in the peer-to-peer applications in general that is a directory phase that is used to locate the content among the pool of peers who are available to share contents. And then there is the downloading phase. Okay. And the directory phase is the more critical one, because it's the one that is most difficult to implement. So in the first peer-to-peer applications, and Napster was the most famous one. Now it's completely different, but at the beginning it started as an application to share also content that was covered by copyright. So the providers of the application were not storing the content. The content was stored by the peers, but they used for the directory phase a centralized architecture. So each time a peer was joining the pool, for example, Alice in this case, the application in her PC, first of all contacted the centralized directory server, communicating the IP address of the host and the menu of the contents that Alice was available to share with the other pools, with the other peers. Then when somebody, for example Bob, wanted to download a certain content, he first contacted the centralized directory server, search for the content in the general menu of the directory server, and then the server returned to Bob the specific IP address or symbolic name or IP address of the host offering the content. So the download phase could start. Okay. Phase number 2. The problem with this architecture is that it is easy to implement, but there are several critical issues. For example, if the server goes down, the system is completely blocked. if the server is received a lot of requests, then the processing capacity of the server can become a bottleneck of the system. But in this case, in the case of Napster, more important of all, the manager of the server can be accused of copyright infringement if illegal content is exchanged between the peers, because there is a centralized site, a centralized directory that is owned by a specific legal entity who is enabling this exchange of illegal content. So the solution was to start to resort to fully distributed architectures, also to implement the directory phase. And one of the earliest applications to apply this concept was Nutella. And how to implement the directory phase in a fully distributed way. The solution is the so-called overlay network or overlay graph. So the peers that are participating to the application connect to the network, and a small number of them are elected as nodes of this overlay network, and they become neighbors each other. Okay. So when a new peer joins, it connects to the neighbor that is closest to the new peer, and then start doing the queries to the directory from the neighbor to which it is connected. Then this neighbor will forward the request to the other neighbors that are connected and in the overlay network, and in this way the query can be solved, that can be processed by in a distributed way. Neighbors are neighbors that is directly connected nodes, but in an overlay network. So geographically or physically, they can be also very far away. So this is an example. If this is the pool of neighbors that are composing the overlay network, imagine that one of these neighbors starts a query or receives a query by some peer that is connected locally to that specific neighbor. Then it sends the query to its own neighbors. The neighbors will forward the queries to their own neighbors, and so on until maybe a certain limit, maximum number of hops is reached. And when one of these contacted peers is able to answer, so he knows where to find the content, or it directly hosts the content in his local cache, it replies with a query hit message that goes back following the same path of the original query. So at the end, the neighbor, the peer who originally made the query, receives a lot of query hits, and it can choose between different possibilities to download the content. For example, it may choose the first query hit it is received, or the closest neighbor, and so on. So then the file transfer may start. So this is basically the way the fully distributed peer-to-peer applications work. And one example is BitTorrent. In this case, not only you have the possibility of doing the directory part in a distributed way, but also the content may be downloaded from different peers, because here the torrent is actually a way to multiplex different information from different sources in order to make up the original content that is required. And this is because the original content can be divided into chunks. Okay? So each chunk can be downloaded by a different source. All the chunks are letters that the peer that made the original request are then put together in order to make up the original content. And here actually there are some servers that helps in the directory phase, but still in a distributed way by keeping a track of the peers that are participating to a torrent. A torrent is a group of peers that are exchanging chunks of a specific file. So momentarily there is this tracker that is able to identify the peers that are participating to the torrent. So this is all. If you are interested to more details, you can find other informations also in the book that is the textbook that I have suggested for this course.